Hi, I'm Radell.
My name's Vaughn, and today we'll be demonstrating how to set up your own honeypot for an internal network. So to start off, we'll begin discussing what a honeypot is.
A honeypot is a system attached to a network intended to lure potential hackers with the ultimate goal of obtaining information about the hacker, such as their IP address and types of commands used in order to notify the defenders of a network.
A honeypot is intentionally made to look vulnerable in order to capture malicious traffic. Honeypots are usually used by large organizations or by cybersecurity researchers who intend to learn more about what methods attackers are using. In this video, we'll be showing how the honeypot reacts with outside traffic on a variety of different ports.
Vaughn and I decided to use Pentbox for our honeypot simulation, mainly because it's very simple to set up and is very user-friendly. Technical Data has the repository on GitHub, and he shows you how to install it in your Kali Linux. So we'll be jumping into our Kali and installing Pentbox to start our honeypot simulation. Okay, so we already have our Kali up. When you download Pentbox into your Kali Linux, you'll use the git clone command. When you receive the compressed file, you'll use the tar command to uncompress it and also unzip it. Once that happens, you will receive this directory, pentbox-1.8, and we could change to that directory. We'll ls to check for the binary that we're going to run, and the binary that we're going to run is going to be pentbox.rb. Just enter. The honeypot will be in network tools. So we'll select 2 for network tools and 3 for honeypot. We want to do an SSH honeypot. So we'll have to select the option 2 for manual configuration. So it can allow us to pick whatever port we want to run the honeypot on. So we'll select 2 for manual configuration. And the port we want to open is 22 for SSH. The false message we want to show, we can say not allowed. And we are going to save the log intrusions. So we'll say Y for yes, hit enter. The default path where these log intrusions are going to be saved is going to be in the pentbox directory and the other directory and as this file. So we'll just hit enter, default okay. We don't want a sound for the intrusion for this. And that's it. Honeypot on port 22 is running. We want to capture the traffic. So let's run Wireshark and get it ready. We're going to be capturing on ETH1. And I'm going to put a port filter to make it easier for us to view. So we'll do TCP port 22, and I will also be showing telnet. So we'll do port 23 as well. We'll wait for that. We have our honeypot running on port 22. Let's start Wireshark before we actually try to SSH into it so we can capture the traffic. And also, let us find out what the IP is for this machine. So the honeypot has the IP of 192.168.56.102. And we'll be using Metasploitable to SSH into this honeypot. Let's also do an ifconfig to look at this machine's IP. Okay, 192.168.56.103. So let's try to SSH into its root. No error. Let's see if we could run some commands. Who am I? ls We didn't get an error, but we're not getting anything back. In the honeypot, we see an intrusion attempt detected. We see the IP, the port number, the date, and the time this intrusion was detected. So we're not getting anything. Let's exit out of there. Control C. And what about if we try to do the SSH into regular Kali? Change roots. We are still not getting anything, but back at the honeypot, we see another intrusion attempt detected. Okay, back in Wireshark, we're able to see the three-way handshake indicating that port 22 is open. However, it is encrypted. So let's see what is actually visible upon the packet inspection. So we did try to SSH into the roots and into regular Kali. So we'll have at least two conversations that we could follow. Although we did write some commands, we are not able to see the commands that we wrote, but we are able to see the default message from the honeypot, which was not allowed. Okay, we weren't able to see much with SSH. Let's try to run a honeypot on port 23, which is telnet. So we'll cancel this. We'll run the binary for Pentbox again. Same settings, 2 for network tools, 3 for honeypot, 2 for manual, port to open 23. False message, we'll say again, not allowed. And we'll save the log intrusions, same path, no sound, honeypot activated. So let's go to our Metasploitable and telnet into this honeypot instance. The telnet, the IP of the machine, and the port number. Port will be 23. Okay. Again, who am I? We are still not receiving anything, and the connection was closed this time. And we see the message this time not allowed in the actual terminal. Back in the honeypot server, it's in the clear, and we're able to see the commands that the attacker wrote. If we look at Wireshark, we can follow these packets. Again, we see the three-way handshake indicating that the port is open. And if we follow that, we see what the attacker wrote, who am I, and the default message that they received back, not allowed. Okay, so now that we've generated some traffic, let's actually take a look at the logs that the honeypot generated. And the logs will be in the other directory. And it will be log honeypot.txt. Let's cat that. And we see honeypot activated on port 23. We see the intrusion detected. And we also see the commands. So the commands will be saved if it's in the clear and if they're visible. With the SSH, unfortunately, we can't see, but we're able to see every intrusion that wasn't attempted. It's detected and it's logged in real time as well.
Okay, so now we'll demonstrate what this honeypot looks like running on port 80. We'll go for a manual configuration. Choose port 80 to open. The false message to show will be Winnie the Pooh was here. Save a log with intrusions, yeah. Default directory is okay, and we're not going to activate a beep. So now it's activated on port 80. We're going to use Metasploitable 2 again to demonstrate what this looks like. So let's say this hacker is in our network. They are aware of our host machine, which is 192.168.56.102. And they're doing some reconnaissance. They want to see what's open. So they run an Nmap scan on our host machine. And they see that one port is open. It's port 80, and there's HTTP service running there. So they know it's a web server. Let's say they try to wget that specific port. So they'll specify the IP address and the port, which is 80. And it'll send the output to something called index.html.2. But they'll get an error here. It says failed network is unreachable. If we go back to our honeypot, it'll show the intrusion attempt detected from that specific IP address, and that IP address's port. It'll tell us the user agent string, what command they used, and yeah. So that's an example of what it looks like from the command line, at least from the hacker. They got something called HTML index.html.2. So if we look what that is, let's cat index.html.2. And it shows our message, our denial message, saying Winnie the Pooh is here. So let's say instead of using the command line here, the terminal, they try to access it from a web browser. So they go 192.168.56.102. And they're going to get that message, that denial message. It'll also log another intrusion attempt from our honeypot. And it'll show the exact user agent string, what they used, Firefox, to access it. And yeah, that's how the honeypot is used on port 80. So to summarize what was covered in this video, we opened honeypots on multiple ports to show that a honeypot can be used on any port with any type of service. We used Pentbox as our open source honeypot script, which allowed us to customize settings, such as which port to launch the honeypot on, denial messages, and where to save the logs. We also used Wireshark to demonstrate the packet capture, specifically showing the three-way handshake between IP addresses and how each honeypot port is open and intended to lure malicious traffic.
Honeypots are commonly placed in the DMZ part of the network to keep it isolated from the main network while still being part of it, so it can be monitored from a distance while the attackers are accessing it. Once intrusions are detected and we have gathered certain information about the attacker, for example, the IP address and commands used that could be considered malicious, the next step would be to contact a system administrator to respond accordingly by either banning the IP address or even tracking their IP address to gather even more information about what it was that they were looking for or what they were trying to accomplish.